and then let me know when we're good to go.
Yeah, okay.
I sent you the project file that he made. Did anybody look at it? The link? All right, so we're going to continue on from there. We're going to be doing the enemy AI. AI doesn't really mean anything since an enemy panel's going to try to catch up with the ball. But when it can't, then you will have ball. So the enemy AI panel is not possible to win the game all the time. So, if you're willing, let's log into my Zoom link. This way you can have questions on Discord. Things going too fast because we're doing the new material. So he was commenting on the code. So the project we have is been commented out and commented. So just like in Python, we have comments for it. It was ready to rock. I don't understand. Okay. So yeah, I like it a lot. Okay.
Log in if you'd like with your camera on. We're gonna have some people log in.
Okay.
All right, let's get it ready to rock. Let's go for it, Matt.
All right. So let's go ahead and pop back to the beginning.
Wow, that's a lot of comments. Cool.
Yeah, no, I commented every level once. So, first things first. You guys control space bar opens up the content drawer.
Hey guys, we're starting here. Please keep it down, like Trin.
So anyway, this is where you get all your folders and your assets and things. This is where everybody lives. This is for all intents and purposes for how it's everything goes in content, and then beyond that, it's kind of up to you. So we have our model folder, and then we have our individual folders beyond that. Inside the map is where I made my level. So you can right click and make a level this way, or if you're on the top of the screen, go to File, we can make a new level that way, and then just save it to our file. Once we have our level, that's when we add a directional light. So we had something to see, or so we had something to cast light with, and then we drop stuff in the level so we had something to actually see with the light. These are just cubes, and we grab all this stuff from up here in the upper left in our place actors panel. This is all the stuff that's included with Unreal Engine, and you can get it all the time in every version. And the last thing we did was we dropped our player start, which is essentially where our pawn is going to be spawned by the game mode when we hit play. We then made the game mode. So over to blueprints, we made our game mode blueprint. This is where everything was starting the classes. In the version I gave you guys, this comment is there. So, and it goes over basically exactly what this is doing. Over here on the right is where we assign our individual classes. So here, our player controller class, the pawn PC. My default pawn class is my pawn underscore BP. So this is where I said, hey, when this game mode is used, use these other classes. then we hit save the file, we close this because we're done. The
Right.
player controller and the pawn are the other two classes we made, and that's to be assigned inside the game file. Over here in world settings is where we said, hey, this level is going to use the pawn game file. You can also set this in the project settings. So this is an override for the level. If you want to set it up here in max and modes, this will be what it actually loads up just by default. We're gonna just leave this the way it is because we're gonna override every level, so it doesn't really matter. But if you had one that, you know, like you were doing like a platformer game or something, and pretty much every level was gonna run platformer, you could just put platformer in here and you'd be done. You would need to override every level. But so this is an override.
All right.
At this point, it's basically set up so the level is going to use our player controller and our pawn and our game file. Does anybody have any questions about any of that stuff? Like the actual setup of the level and the framework we have going on. Any questions about any of that?
Yeah, I would log in on this Zoom account. I think some people are still logging in.
Okay.
Any questions on this if you're not logged in? All right.
All right. Everybody's good on this?
Yeah.
Okay. So question. Wait, like, you have a question?
It's all good.
All right. So the player controller is where we set up our inputs. So this is where we said, hey, when we possess our guy, we want to turn on this set of inputs, and we want to listen for these events. This is what we made over here in the input folder. The input action is the actual thing. This is, move, jump, shoot, roll, whatever. This is the individual action. The mapping context is the list of actions associated with any given context. So, if I'm doing, you know, like actual gameplay versus using a menu, or if I'm doing, you know, like walking versus on a mount, or, you know, literally any variation of things. Where, you know, I want the same button to do different things because I'm in a different context. You would set up a different context mapping, and then you can add and remove these from our input subsystem. So here we have move, and we define the A and D. D, right, A, and left are their inputs, and we added modifiers to A and left so that they will give us -1 instead of 1 when the input is pressed. And then here we said, hey, use that mapping context. So basically listen for those buttons. That's all we really had to do inside the controller. And then inside the pawn itself, here is our move action. This is the one that we set up in the context mapping, and it's going to return either 1 or -1 depending on if it's a right or left, because we negated our left inputs. So they'll give us -1 instead of 1 because they're pressed. We're then getting that's the action value right here. So this is the 1 and the -1. We're taking our right vector, which means our local right. So the green arrow for this guy, not for the world. And then we're multiplying that by our speed and our depth seconds. So 1 or -1 times this is going to give us right or left. And then our speed times our delta seconds is going to give us how much we're supposed to move
this
this frame.
So,
So,
you know,
if it's been 0.1 seconds, then we'll move a tenth of our speed.
So,
So,
you know what I mean? And
and then we multiply these all together,
and
and then we add this to our current location to get our new location. So this is our offset,
and
and then we add it to our new location, or to our old location, and that gives us our new location. And then we said bump into stuff if we happen to hit something on the way. And this is going to make sure that we don't just sort of slide through things. Does anybody have any questions on that part? The inputs, the controller, or the actual pawn setup?
We're all good. Unless, Evan, you have a question? All right. Download the package that's on it. That I put the link on in Canvas so you have it moving to the office. Okay. What I told them to do is I put the link to your package file on Google Drive, so some people are going to download it. So let's just carry on the new stuff.
all right.
Let me finish rolling back on that stuff real quick. So
The
the
ball,
ball, this is our refresher.
we
We
set
set
up
up
a
a change direction
function
function
where we
where we
get
get
a random
random
float
float
for
for X and for Y, and we
normalize
normalize it and make that into our direction. We call that a begin play, so we just basically pick a random direction, and then we save our starting location. Then on the first tick, we move our ball in the direction based on our speed and delta seconds. So just same as before, except we're not using a scale value for this. We're just going in a direction. We're also not adding to our old location because add after offset knows where we are. We just have to tell it what the offset is. So that's the main difference between these two functions here is this one does not know where you are. This one knows where you are. Then we check to see, because we're still blocking stuff, did we hit something? If we did hit something, then we take the normal, or like the direction the surface was facing that we hit, and our direction, and we figure out how to bounce off of it. Normalize, just be safe, and make sure we're going in the flat direction. And then set that as our new direction, and then we update our ball speed just for fun by some random amount. You guys don't actually have to do that, it's up to you.
Here we go.
And then we have our respawn function down here, which actually changes our direction again and sets us back to the beginning. And then this part would set the ball speed back to its initial speed. It's not connected though, so that's not going to happen right now. However, if I connect this, then it would happen. And then the last part here is where we left off with our goal. And basically, we have our little box line here, and when something overlaps the box, we check to see, is this thing the ball? If it is the ball, then we call respawn on it, because we have access to the ball and its functions now, so we can just call the respawn function. And that will then trigger said change direction and put it back in there. Does anybody have any questions about how any of this works so far?
Let me not.
Everybody, I think you should download this file. This is on Canvas, so take this file, download it, and put it over here. Not sure because we can use this to jump off on a friend. You know where this file is? It's on Canvas. So please do that. Paul, how are you doing? Okay, did you ever download this file? Yeah. So we're gonna go to do stuff. This file's on Canvas, and this way you can carry it. Questions for me?
What people are doing, they're downloading the file. I put the link on Canvas. So, and then that'll help out. There we go. What is being casted to an odd event if actor begin overlap? Okay.
So
Casting is literally saying I have this thing. Is this thing actually some more specific thing? So,
hey,
hey, give me that bag.
You mean the
You
red
want the
bag
red
or
bag
the
or
blue
the
bag?
blue bag?
You know what I mean?
Like it's
specifically
narrowing it down.
So
So in this case, everything in the world is an actor because it has to be. In this case, what you're going to see is the ball, or is this actor actually a ball? Okay.
All right. So next we're going to go ahead and do the AI, and we'll do scoring last. So just like before, we need to make a new class. So we go to my blueprints folder here and right click. Now there's a couple ways we can do this. We're going to do this the super simple way. So I'm going to go ahead and just make this an actor. However, we could make this a pawn, and that would give us access to some more stuff, like for more advanced AI. We're not going to bother with that for now. We're just going to go ahead and stick with actor. Actually, we'll make it a pawn just in case you guys want to do that. There's really nothing stopping us from doing that, but we'll go ahead and do it this way. AI underscore Tom underscore Ping. And again, the way I'm naming this is so that I know it's the AI for the Pong game, but I don't actually care about Pong that much. So AI goes first, then Pong, then it's class because the thing I care about is the way I'm doing the convention. You guys can do it however you like. Most important thing really is just stay consistent, especially when you guys have to play teams. So we're basically going to remake our pawn, except I don't need a spray gun or a camera, so it's going to be a box collision and a static mesh. So I'm going to go over here and going to add a box collision. And we're going to go ahead and add a static mesh. And then, just like before,
I'm going to change my stance, my box here to 50, 200, and 50. And I'm going to set my box to be a cube.
And I'm going to scale it up to 4 on Y. And then we're all good now. And then I'm going to set this to block. And tell this to that bar. Alright. So now we have our actual AI dude. Is everybody going to know how to do that?
How come you have this on no collide? I mean, no collision.
So
the
static mesh is on
all right,
and box is on block hall.
Okay.
This is going to handle a collision. The static mesh itself is going to kind of just be there for us.
Right. The idea with this is you could replace the static mesh with your own geometry, more detailed geo.
Yes, you can. if you do that, you'll
essentially
essentially have to just replace the box. So like in that case, we would drag the static mesh up here, and then it would just be the root.
Doing it this way is more simplified because we're kind of going for the old school thing, but
yeah,
yeah, you can absolutely do whatever kind of weird geometry you want. You would just have to make sure that your static mesh was the root. That way, we could use its collision for our movement checks.
All right.
Got a question from Jordan again. Let's see.
So the extent for this is 50 on X, 200 on Y, and 50 on Z. And then the scale for the static mesh is just 1 on X, 4 on Y, and 1 on Z.
All right.
So there's no other questions about how to set this up. We're going to go over to the event graph, and
we're
gonna again need to set this up to actually I need to. We're gonna set this up to basically chase the ball. So once again, we need to set up our movement thing. You'll find this is a fairly standard thing we're gonna do. So over here times speed. And in this case, I just need a float for direction because he's only going to go left and right, unlike ball. So speed, set these speed, we're going to go 300 because I think that's what our character is doing.
Yep,
he's doing 300, so we're going to do 300 there. And then direction will start with 1, just because, and then we can adjust that later. Then we want to go ahead and add actor offsets. And we're going to pick local because, again, I want him to move left and right based on how I place him. So we're going to go ahead and right-click, split this open, and then plug this to Y, and that'll get us going left and right based on this local organization. And then turn on sweep, and now it will move back and forth. Well, right now it'll go to the right. We need to check and see where the ball is, and then adjust accordingly. So we can do this a couple of ways. We could dynamically get the reference. So on begin play, I can pull up here and type in get actor of class, and then pick ball, and this will just find me the first ball that it finds in the level, and it'll give me the reference to it. I can also get all actors of class. This will return an array. So this will return all of them. And then I can pick which one I want if I want to do it that way. We're not going to do it like that just because that's kind of the last resort. Since we know that there's going to be a ball to see and we're not going to get rid of the ball, we're going to just assign, we're just going to hard code it and be done. So over here on the left in the variable section, I'm going to make a new variable. I'm going to call this ball ref. And then over here under variable type, I'm going to go ahead and pick the ball. So ball BP. And it's going to ask me if I want an object reference or a class reference or a soft class or object reference. We want an object reference because this is an actual instance of the thing that I want to point to. The class reference is going to be like the idea of the ball, not a specific ball, just
The
ball class. We could use this to spawn things or to get default values out of it, but it's not particularly helpful in this case.
I
I want to know where the ball in the level is, so I want the object one.
Okay.
And then we're just gonna leave it as a single because I want one, but this is where you can set, array, map, whatever, if you want to have a different container type. And so I have a single reference to a ball, so it's gonna hold one. I'm then gonna make this instance editable, so this little checkbox here. You'll notice this little eyeball over here on the left over when I did that. These are the exact same setting. So when I click this little eyeball, that little checkbox goes away. When I open the eyeball, checkbox sits. So these are the exact same thing. If I hit compile and save, and I come out here to level, I can now drag one of these guys in here. I need one. And here in the details panel, you see there was a ball rep spot there. I can now actually pick from this little drop down all the balls at the level. If there was a bunch, I can put the eyedropper and then just actually select the one that I want. Either one works. But now it knows about this ball. Right? Let me go ahead and put this guy in his place real quick. Spin like so. Let me double check. Okay. Hold on. Yeah, no, he's backwards. There we go. So this little button right here switches between world and local, so you can see what the orientation is. So this is his local orientation. So this is to the right, this is to the left, and this is looking forward. So this is correct. All right. So now I got what I want. I'm gonna go ahead and back inside. And I have a reference to the ball. You don't actually have to set this ahead of time. Like there is no default value for this at the moment. This says none right here. So there is no I don't need to set this. I just did that because. We want to go ahead and get the location of this. Nope. And I want to get my location. And I'm going to find out if this is to the right or the left of my character. So the easiest way to do this is just based on a world, and that's fine because what are you doing? That's very weird. Okay. Anyway. So I just need to know if it's higher or lower than me on the y-axis because that's the one that's going down the middle of the board here. We can do more math to figure out the local load. So we're gonna split these both open. And then I want to know is the y for the ball greater than my y or not? And if it is, we're going to flip basically. So if I go ahead and do a branch here, it'll let me pick two different paths. This is fine, but this is going to be a little messy. So instead of doing that, we're going to do a select. And then I can select a float.
So if
if
it
it
is
greater
greater
than
than mine,
mine, or not, wait, hold up.
No,
No, why not? If the X is greater. We'll go with the red arrow. Sorry.
Yeah,
If the X is greater than mine,
then
I want to go to the right. Because this is positive X. So if your X is bigger than mine, that means you're over this way more than me. So I want to go to the right because looking at this orientation, this green arrow is to the right. So we want to go to the right if the X is larger.
Whoops. That's one. There we go.
Where is mine?
Yeah. So if
the ball X is greater than my X, I want positive 1.
If
If it is not,
I
I want
negative
negative
1.
1. And then
we're
go
going to
ahead and set direction. And now it will move with the ball. So let's go ahead and test this real quick. Is anybody confused about why this works or how this works? Or what to do? Fun. Enemy AI.
Yep.
Now, anybody notice that
it's looking
a little janky? Very janky.
Wow. Go to the side.
Man.
There we go.
There we go.
So
the reason we're looking a little janky is because there is no
middle
middle
ground.
ground. It's either yes or no. So like, if it's part of a way, it looks fine. See? Yeah. But as soon as it starts hanging out in the middle-ish, then it starts going back and forth because it's, like yes, and then it goes a little too far and goes back to the right. No. So what we want to do is we want to check if it's too far to one side or the other, not just is it flat, like greater than or less than. So there's a couple of ways we can do this. One of the ways I'm trying to remember how I usually do it. But we can basically just do is in range. You know what? Actually, I don't. Yeah, that's fine.
So I subtract this from that. Hit the absolute. And then just check to see if this is actually greater than or less than some amount. So here's going to be my range. And I'm going to put this to a variable just in case I want to mess with it later. No, wait,
I want.
Not random.
Yes.
I don't want to do this whole bunch of goofiness. Oh, it's just
Okay.
There we go. Max to min range. If it is within the range, then we're not going to do anything. So if it is in range, then we're going to leave it 0, and if it's not in range, then we're going to go ahead and actually do our select float here. And then we will do our other little check, which was is this greater than? There we go. All right. So still checking if it's greater than to go no more left or right. But we're going to check and see, is this within a tolerance, basically. So we shouldn't be, bothering with it. I need to compile, and then our range is going to be 25. And then let's go ahead and hit this, play. Still a little bit janky, but that's because he's moving too fast. If I bring this down a little bit, that'll be better. And actually, as you can see, he slides way too quickly. I'm not actually sure. What's our speed set to 300, right? Why does he move faster?
You're a superior player.
Again, I guess he doesn't move faster than me. Actually, balls just move too fast. So let's go ahead and bang that down a little bit. Actually, no, we'll just make the ball go faster. I like that better. So we'll make the ball go 600 just for fun. And then now we shouldn't have as much problem with this because we are running back a little bit. All right. Anybody not have a moving AI?
I'm recording this as well. So if you're stuck, we're going to have both the project file, this one, and also the video. I've got a question, Matt. What if they wanted to okay, let's answer Jordan's. What did you attach to event begin play in the AI poem?
Double check real quick. Yeah, nope. I just had to check.
And Matt, what I'm interested in doing is I know it's simple, but take the camera and not have it parented to the controller, so we can just move the controller independently of the camera.
I can sort of kind of that. Actually, unparenting it from the camera would be, or from the controller would be mildly annoying. Not real annoying, but just a little bit. However, the spring arm has options.
Okay.
Where are my options? There we go.
You put it like 0%.
Yeah. So if I do this, I just want to double check that this works. Yeah, no, this is probably
That's probably
not
what I
work.
want to do.
That's okay.
That's okay.
Yeah,
Yeah,
we can
we can go ahead and
separate
separate
it.
it.
In
In order to do that,
we'd have to actually
delete
it off of here,
and then drop it onto another, like drop it on the rack. So
I'm gonna
I'm
go
gonna go
ahead
ahead
and
and
I'll
I'll
do
do
this
this
for
here
real
real
quick.
quick.
Go ahead and grab
Grab
up here at the top.
We're gonna go to
cinematic.
cinematic.
No, we're gonna go
All of this.
And we're
I'm
gonna
gonna grab me a camera actor because I don't need any special for this, to be honest with you.
We're
We're
gonna
gonna
go
go
ahead
ahead and
so
I'm gonna right click on this guy and pilot camera, and now I am in camera. So this is gonna be
the
the
view
view
that
that I get when I'm done with this.
Cool,
And then I'm gonna hit eject up here on the left, and then that's gonna be my new camera. And then I'm going to hop inside my pawn here. And then on begin play. This one I am gonna have to actually get dynamically because this is gonna like this actual pawn is gonna spawn into the level. So I don't have I can't click on it and tell the camera ahead of time. So this one I have to grab like this.
I'm gonna
Hit
actor
glass.
and
And there is only one floating camera actor in the level, so I don't have to actually worry about that one so much. I can just grab the first one, and then I want to get my controller. Actually, you know what? Let me do this in the controller class, actually. Since this is like the controller is the one that's doing this, we might as well. Just one. Actor class. Camera actor. And then we're going to set view target with blend. And then this is going to be my new target, and self is going to be the target for this because the controller is the one that actually is in charge of this stuff. So having that set up, compile save, and now I go back to level and hit play. I am in my not quite even camera. It looks fun. Easier to see.
Yeah, so
let me go ahead and top down.
Here's my camera. Rotate. Too much. There we go. That's still not quite right. Yeah, let's do it this way. There we go. All right. A little bit. Actually, pick this up like that. I'll just rotate it forward. Alright, and then hit play, and yep, now I got my view. So
just to recap, in order to do that, I got rid of my camera and spring arm out of here. So now it's, basically the same as the AI guy. And then inside the controller, I got a hold of the only camera actor on the level and then set my view blend to it. So now I'm through that camera instead of through, the other one. That is no longer there. Anybody have any questions about how that works?
Did it say
So could not access, and it said access none.
Right.
Access none means that there is no reference. So out here in the level, if you click on your AI, is the ball ref set to something? So that's the key to doing the direct references like this one is you have to actually tell it like this one specifically. Whereas the other way I did it, it's going to just find it on its own. I'm gonna. So the other way to do this, like, come on, there's one other way to do this that's a little smoother that I kind of want to go over real quick. Have you guys heard of interpreters, like interpolation?
No.
No?
No?
All right,
So interpolation is like moving from one place to another, typically over like a curve. So if I do B interp 2,
Mhm.
and I want constant. This is essentially going to handle going from wherever I am now to where I want to go. So I could do this. Recombine. So this is my target location. This is my current location. Except I don't want to go to where the ball actually is. I just want to go to where it is on the Y. So I do actually. So well, actually, you can go there and break this from this. So anytime you take a break, it'll give you a separate node instead of splitting it open like this. It just depends on what your needs are. So I want to stay on my Y and my Z, and I want to go to the X of the ball. And I want to do that delta time, and then interp speed is essentially like how quickly I now 300 is going to be a little high for this, so I'm going to go ahead and just type in interp speed of like 10. And we'll see how that goes. But so if I plug this into here instead of down there, and I turn on sweep, compile save, and I play, that's too slow. Maybe 300 was slow. There we go. Yeah, 300 is fine. So, almost got it. So that's kind of the problem with that one. But you'll see this is like a much smoother.
there is no jittering because it's trying to go where the ball is. So if it gets there, then it just stops, and if it doesn't get there, it just keeps moving. So and then so that's the other way to go. This is just a bit more. I don't know. It's a little janky. I don't like this much. So I'm going to get rid of that. Stick with this. We'll go ahead and stick with speed here. Okay. All right. So this will be the new one we've done. Anybody have any questions about how this works or why?
How far do you get? Oh, okay. All right. All right. So this is recorded, and we'll. Can you zoom in on your graph?
So active location for the AI is going into current because that's where we currently are. And then I'm also breaking this open and using my Y and my Z because I want to stay on my Y and my Z. And I'm just getting the X from the ball location and setting X my target. So I want to go to whatever X spot the ball is at. And then delta time and turn speed work the exact same way as before. This is just working over a curve to try and move you to the exact location of the ball instead of what we were doing before, which was kind of like, pushing you either one way or the other and not really, letting it rest. Any other questions about how the AI works or how the camera thing works?
Yeah. So he's saying, what do you think of this question?
So the pawn, the reason you use pawn is if you want to have inputs. So whether it's an AI pawn or a player pawn, it's going to be assigned a controller. And then the controller will either take input from the player, like the input subsystem, or it'll let you run things like behavior trees and state trees to get much more complex behavior. This might as well be an actor because we're not utilizing any kind of pawn anything here. But pawns get access to like movement components and nav meshes and behavior trees and all kinds of stuff. So using a pawn is for if you want like complex movements based on either your input or a behavior tree. Same thing with character. Characters are more specified to like a character. Any other questions?
Anybody have any? everyone looks good. So they're going to work on this, reviewing the video. And if you could give me this file, I would be appreciative of that. Then I'm going to put it on my Google Drive so they can download it.
I got you. Yeah. Okay, what we have. But yeah, I'll comment on this stuff and stay together.
Awesome.
Do we want to keep this separate camera?
Yeah, do you guys like the separate camera? I kind of like separate camera better, but what's your opinion? Meaning the camera's still not moving, stationary. Separate camera. Stationary camera, please. Yes.
Okay. All right. And then next time we'll do the actual scoring and the UI to let you know what happened.
Cool. Yeah.
And then it's the main menu and wrap it up. And at that point, it's just going to be polishing of whatever you're going to do.
Awesome. Yeah.
All right. Another question?
We're good for today.
All right.
Thanks.
I'll see you guys later. Bye.
Bye. All right. Video will go back up.